answer because I probably wouldn't use long division on this one. But what number or what multiplied by x gets me x cubed or x to the fourth? Well, that's x cubed. That line becomes x cubed times the binomial. Subtract, I subtract 0 or negative 2x from 0. I have positive 2x cubed. Bring down my 3 and work my way through. Now, I may have made a mistake. I don't know. I made mistakes before. Do you think I made a mistake? Because I can. Okay. So you're right here at the first line. Right at the first line here. Or not. Okay. 2x cubed. So 0 subtract a negative 2x squared. Or sorry, negative 2x cubed. So 0 minus negative 2 is going to give you that positive 2. And that's why I have, in certain situations, I'd much rather do synthetic division because it's adding. So setting up my synthetic division, I have to still have the same principle. I need to include everything. So I got 1x to the fourth, 0x cubed, negative 3x squared, negative 5x, and 2 at the end. I'm just putting that line to distinguish. Sean, what goes here? Negative 2 or positive 2? The 0 of this function. That's how I remember it. It's actually, we're dividing by x minus a positive 2. We're dealing with that positive 2 that's there. Now, since I'm dividing x to the fourth by x, I know my term is going to start with a 1 because I'm just dividing by that 1x. Multiply, add them together. Multiply 2 by 2, add them together. Multiply the 2 by 1, add them together to get minus 3. 2 by minus 3 is minus 6, and we end up with a minus 4. I'd much rather do this one. It's easier. But what we're looking at right now is the remainder. Well, we can now make this assumption, because the remainder is negative 4. It's not an assumption. We know that x minus 2 is not a factor of that polynomial because the remainder is not 0. Now, kind of ran out of room here. I want you to evaluate p at 2. So that means I want you to plug in 2 every place you see an x. I would like you to do that on your calculator. Well, when you plug all that into your calculator, what do you get? Yes? Negative 4. This works out to be negative 4. And what you should notice, negative 4 was the remainder that we got in both cases. So again, this 2 in the p at 2 is the 0 of the divisor. Okay. So basically, if we evaluate at the 0 of the divisor, in this case, we got the same remainder. We got the remainder of -4. Now, that leads us to the remainder theorem. Now, where does this come in? Quite often, I just want to know if something's a factor. Or, what is the remainder when I divide this polynomial by this number? Now, I can go ahead and do long division, or I can do synthetic division. But the remainder theorem is easier, or quicker, I should say. Not easier, but quicker. States that a polynomial p of x is divided by a binomial x minus a. The remainder can be determined by p at a. So what is the 0 of that divisor? Now we can take it a step further. If it's not just x minus a, it's 2x minus 1. We can find the remainder by evaluating at b over a. So if the divisor is 2x minus 3, we would want to evaluate at p at 3/2. Because again, that's the 0, or 1.5. That's the 0 of the function, or of the divisor. So we want to see where we go from there. That is the useful thing in this case. If I only want to know the remainder. Now, the biggest time that I want to know the remainder is this a factor? Before I go ahead and do this long ass division here, maybe I should see if it's a factor for it beforehand. Now, I have to know how to do long division. We have to know how to do long division, because if the divisor is 2x minus 3, we can't do synthetic division. Okay. We can, but it requires a little bit more work, and I don't want to go there. Either do synthetic or it's long division. I want to know when a thing is a factor. Okay. So with these three things, I have no desire. I don't need to do long division or synthetic division. I just want to know what is the remainder when we do this. So here's our polynomial on top, p of x, and I'm dividing by x minus 2. So what am I going to evaluate this polynomial at? 2 or negative 2? Negative 2, the 0 of that function. The other way, I use the 0, but it's actually, we're evaluating it at the 2 at the end, because it's always x minus. I like using the 0. So we want to evaluate p at negative 2. Negative 2 cubed plus 3 times negative 2 squared minus 5 times negative 2 plus 2. So we have negative 8 plus 12, so now we're at positive 4, plus 10, we're at positive 14, plus 2, positive 16. Unless I made some error. Sean, did I make some error? Okay. So, again, yes? Okay. Again, I'm just saying you should be able to do it in your head. I know I make mistakes too. So, all I'm saying is if I was to do that long division or that synthetic division, I would get out 16. So again, most importantly right now, this x plus 2 is not a factor of the guy above. So I would like you to evaluate this polynomial, p at t, because we're talking about t as a polynomial, or as a variable in this case. So I'll go ahead and evaluate p at positive 2. I don't know why there's a negative sign there. 4 minus 32 Probably better if you pay attention to this. So what do we get when we plug in 2 in for t in this case? Aurora. So again, the remainder when we divide 2t minus 4t cubed minus 3t squared by t minus 2 is minus 40. Again, there are times where this is useful for us, knowing the remainder. Sometimes we know it's not a factor. That's the important part. This polynomial here, we're dividing by 2x plus 1. So we want to evaluate this polynomial at negative 1/2. Because 0 of 2x plus 1 is 1/2. So essentially I'm doing that in my head, getting the right 0. So I'm going to plug in negative 1/2 every place I see my x. And it's important that you make sure your negative signs are in brackets. If you go negative 1/2 cubed without the brackets around the negative 1/2, you're going to get, well, that one you're going to get the right answer, -8, but it's the squared one you won't. So I've got negative 1/4 minus 7/4 plus 2/4. Probably this one probably is easier to do on a calculator. Oh, what did you get out for it as an answer for this? Positive 3 doesn't sound right to me. Because I'm going, well, maybe never mind, because that's a plus. So, anybody else get positive 3? Okay, I messed up. I had a negative sign in my head there. So positive 3 does sound right. Okay. So again, that's that's what we do. It's that again, not a factor. 2x plus 1 is not a factor of that because it has a remainder. Now, a couple ways that we will ask you to do this is using, well, some stuff that you did last year. Here we are, okay, so this one, what are the values of c? So we have an unknown variable c, that these two guys have the same remainder when it's divided by x minus 2 and x plus 1. So incorporating what we have here, I really don't want to do synthetic division. I can't really do synthetic division with this. What I'm saying, since they have the same remainder, well, I want to do a remainder. So p at 2 would give me the remainder if I divided by x minus 2. P at negative 1 is going to give me the remainder when I divide by x plus 1, whether I do it with synthetic division or long division. Since they have the same remainder, they're equal to each other. So let's go ahead and plug in what we have. We've got negative 2 cubed plus c times 2 squared minus 5 times 2 minus 2. Over on the other side, negative 2, negative 1 cubed plus c times negative 1 squared minus 5 times negative 1 minus 2. On this side here, we've got negative 16 minus 10 minus 2. So we have negative 28 plus 4c on that side. I'm just gathering the numbers. Here I have positive 2 plus 5 is 7. So we end up with 5 plus c. I really didn't give enough room. I'm sorry about that. So we've taken the question and we've turned it into a linear equation. I have an equality. P at 2 is equal to P at negative 1. We're going to have, bringing all c's to one side, we have 3c is equal to 33. C is equal to 11. There are a couple ways of asking this that I haven't covered. If I give you a polynomial described like this, now, there's only two possible choices here because I haven't given you any numbers. Now, right now I can only say that when I divide it by 2x plus 3, so I'm going to try to evaluate that function at negative 1.5. Now, if I wanted to know the remainder, I would go over to negative 1.5, I would go up, and I would find what my value is at that point. So instead of algebraically determining it, we are graphically determining it. Right now with this question, I can just say that the remainder is positive because I haven't given you any numbers on my y-axis. So you can evaluate it graphically too. Again, okay, so they're asking us divide. Well, I'm going to evaluate at p at negative 1.5. Factor theorem. You've probably figured out I'm leading up to factor theorem because it is very useful. The divisor is a factor of the dividend, i.e. what we're dividing into it, when the remainder is equal to 0. So the factor theorem states the divisor, now ax minus b, the a can be 1, is a factor of the polynomial if we evaluate the polynomial at the 0 of this guy and we end up with 0 getting out of it. So we want to know if these guys are factors. And there are 3 of them which are factors. Now in this case, p at negative 1/2. And I'm going to show you a shortcut for this in a minute. But we're evaluating at 2 times negative 1/2 cubed minus 5 times negative 1/2 squared 28 times 1/2 plus 50. Now, I'm going to bring up my calculator and I'm going to show you a shortcut if you're asked to evaluate this multiple times with the same polynomial. All right. So, if I want to evaluate this function, I could plug that all in. But here's a shortcut that makes your calculator work a little bit better. So I can't remember what the function was. So, if I punch this in like this, and I hit enter, it's going to give me some number. Okay? Doesn't really matter what that number is. But I want to evaluate this at negative 1/2. So to get my calculator to do this, I'm going to go negative 0.5. I'm going to store it into x. Now that means I've now put negative 0.5 in for x. Okay, so the store button is next to the 1. And then what I'm going to do is I'm going to go grab that. Now, who has an 83? Anybody have an 83? Alexis, you got an 84 or an 83? Okay, so you're good. All right, good. I don't have to worry about it. Now I just go grab it. What this does, it plugs in negative 0.5 into my equation, and we got out 27.5. Okay, it's not a factor. The next one that they're looking for is we want to evaluate at p at 3. Sorry, p at negative 3. So I'm going to go back and I'm going to go to my calculator, negative 3, store into x. Hit enter. And then I'm going to go grab the equation that I want. Oh, hello. Yeah, it takes some time setting up, but it's easier than otherwise. So since p at negative 3 is equal to 0, this is one of our factors. Please go find me the other two factors I've got listed here. Plugging in -5. And -20. Most importantly, not 0. Y store into X. Five works, and 0.5 store into X. And 2x minus 1. So P at -5 doesn't equal to 0. P at 5 does equal to 0. P at 1/2 equals to 0. Factor, factor, not a factor. So, the polynomial in factored form. Well, one factor was x plus 3. Another factor was x minus 5. And the third factor was 2x minus 1. So, that polynomial, when we do all our factoring, and do that. And now, it's an easy way to avoid synthetic division or long division, but quite frankly, we aren't as nice. We need you to know how to do both of those terms. So the factored form is just the three factors that we found by using the factor theorem. Couple things that we're going to look at. Notice what the coefficient or the constant terms in our binomial multiply to. They multiply to a positive 15. So if I don't give you possible factors to test, how did I come up with x plus 3, x minus 5, 2x minus 1, and the other two up here? How did I come up with them? We'll talk about that when we get into the zero, integer zero theorem. So I would like you, before we go on, is there any questions on the factor theorem? The factor theorem is where we're going to start. I'm going to give you that polynomial. I'm going to ask you what are the factors of that polynomial. I'm not going to give you what I'm dividing it by. We're going to use a offshoot of the factor theorem tomorrow to figure out which one to test. I'm going to test 1, 2, 3, and 6 and -1, 2, 3, and 6 because they are factors of 6. So please do the whiteboard work.